Hi everybody, this is example 5 from chapter 12 from our student packet. And it says that Mars Incorporated manufactures bags of peanut M&Ms. They report that they make 10% each of brown and red candies, 20% each of yellow, blue, and orange candies, and the rest of the candies are green. So before I go and answer any of the questions, I'm going to gather all of the information that we know. So we know, I'm going to put it down here in yellow, we know that the probability that a candy is brown, so I'm going to use B, is 0.1, and the probability that a candy is red is also 0.1. And then we were told that the probability that a candy is yellow is 0.2. The probability that a candy is blue, I'm going to use BL for blue, is also 0.2. And the probability that candy is orange is 0.2. And we need to find the probability that a candy is green. These are all the colors of the candies, so we know that in the end, all of these probabilities need to add up to 1. So if we add the probabilities that we know, so 0.1 plus 0.1 plus 0.2 plus 0.2 plus 0.2, that's going to give me 0.8, which means that the green has to be whatever's left over to get us to 1. So if I take 1 minus 0.8, I will get 0.2. And now if I add up all the probabilities, they'll equal 1. So now let's go up and answer our questions. It says, if you pick a peanut butter M&M at random, what's the probability that it's green? Well, we just figured that out. We know the probability that it's green is 1 minus all the other probabilities, which gave us 0.2. Now it says, what is the probability that it's a primary color? Now, first note that there's no way that a candy, an M&M, is more than one color. So when we're doing the addition rule, we don't have to subtract off the intersection. So we're finding the probability that a candy is red or yellow or blue, which means we're finding the probability that a candy is red plus that the probability that the candy is yellow plus the probability that the candy is blue. Well, the probability that a candy is red is 0.1, yellow is 0.2, and blue is 0.2, giving us an answer of 0.5. Part C says, what's the probability that it's not orange? So we are finding the complement of the probability that it's orange. So the probability that it's not orange, there's a couple ways of writing not orange, but I'm going to use the notation where I make a little C up above. Well, the complement that a probability is not orange is 1 minus the probability that it is orange. And we know that the probability that it's orange is 0.2, which means the probability that it's not orange is 0.8. It says, are picking M&Ms independent events? Now, later on in this chapter, we are going to learn how to use formulas to show that two events are independent. But right here, we are just going to use our logic, and we're going to say yes, because we know that choosing one M&M does not affect the probability of the color of another M&M unless we have an extremely small bag of M&Ms. So yes, choosing one color does not affect the probability of choosing another color unless the bag that we are choosing from, the sample that we're choosing from, is small.